Hello, in this video we're going to look at SAT economics and business related questions. Question 1. A firm produces boxes of nuts and boxes of bolts. The total cost of production is given by the following equation. If the total cost of production was $40,000 and the firm produced 3,000 boxes of bolts, how many boxes of nuts did it produce? So start with our equation here, and we're going to substitute in what we know. The total cost of production is $40,000, so C will be $40,000. And we know the firm produced 3,000 boxes of bolts, so for B, we're going to plug in 3,000. So making those substitutions. And now we're going to solve this equation for N. So first 8 times 3,000 is 24,000. Then I'm going to subtract 24,000 from both sides. So 40,000 minus 24,000 is 16,000. Then we're going to divide through by 10. And the firm produced 1,600 boxes of nuts. Okay, another question. Question 2. The line graph shows the total cost of producing guitar strings. According to the graph, what is the cost of producing an additional guitar string? The cost of an additional string is given by the slope of the line. So to calculate the slope, we're just going to use any 2 points on this line. I'm going to use here this vertical intercept and this point over here where number of guitar strings is 10. So the height between those 2 points, or the rise, is going to be 5, 10 minus 5. And then the run, or horizontal distance between those 2 points, is just going to be 10 minus 0, or 10. So rise over run here, we get an answer of 5 divided by 10, or 0.5, and that represents 50 cents. So the cost of additional string in this example will be 50 cents. What about the cost of producing 33 guitar strings? We're going to need the total cost equation for producing guitar strings. And the total cost will be given by the vertical intercept plus the slope times the number of strings. The vertical intercept is 5. The slope, as we just found, is 0.5. S represents the number of strings. So now we have our total cost equation, and we're going to plug in 33 for the number of strings. And we simplify here, and we get a value of $21.50. Okay, moving on. A firm purchased a piece of equipment for $80,000. The machine depreciates by a fixed amount each year. After 3 years, the machine is worth $50,000. Write an equation that gives the value V of the machine after T years. Total depreciation after 3 years is going to be $30,000. We bought the machine for $80,000. After 3 years, it's now worth $50,000. So the firm experienced $30,000 of depreciation over 3 years. And since the machine depreciates by a fixed amount each year, the annual depreciation rate is going to be $30,000 divided by 3 years, or $10,000. So this machine depreciates $10,000 each year. So we want to come up with an equation that gives the value of the machine after T years. So the value of the machine is going to be the purchase price minus the depreciation multiplied by the number of years. So for example, the purchase price here is $80,000. We determine that the annual depreciation is $10,000, so that will be our formula. We could check this. So for example, if T equals 3, what is going to be the value of the machine at the end of 3 years? It'll be $50,000. So we did our math right here. We got the right equation. All right, let's move on to another question. The cost per pound of bananas is 75 cents per pound. What is the total cost of X pounds of bananas? The total cost will just be 0.75 times the number of pounds of bananas, which is represented by X. Next question, question 5. Between years 2000 and 2018, the amount of steel produced is represented by Y equals 4X plus 25, where Y is millions of tons of steel produced annually, and X is the number of years since 2000. What does the number 4 represent in the above equation? So 4 here in the above equation, that's going to be the slope. So that's going to tell us the annual increase in steel production between the years 2000 and 2018. What is the estimated total steel produced in year 2002? Okay, so using our equation here, X, again, represents the number of years since 2000. So if we're in 2002, X here is going to represent 2. We're 2 years away from 2000. And so just doing the math here, 8 plus 25 is 33 million tons of steel were produced in year 2002. Okay, moving on to the next question. The monthly total cost of a tennis club membership is given by the following: y equals 30 plus 5x, where y is measured in dollars and x represents hours of play. If this equation was graphed in an xy plane, what does the vertical intercept represent? So the vertical intercept is going to be the flat fee of the monthly membership. So the vertical intercept is 30, and that's going to represent the flat fee of the monthly membership. Question 7. There's a one-time service fee to purchase concert tickets. The cost of purchasing concert tickets is given by C equals 25x plus 5, where C is the total cost in dollars of purchasing X tickets. What does the number 5 in the equation represent? Number 5 is going to be the fixed service fee. A lawyer charges a firm an annual retainer fee of $16,000 plus $300 for every hour of legal advice. For the entire year, the firm paid the lawyer $76,000. How many hours did the lawyer work for the firm? So we're going to set up the cost equation. So cost equals the retainer fee plus the lawyer's hourly rate times the number of hours that the lawyer worked. We know the cost here is $76,000 for the year. The retainer fee is $16,000 plus the hourly rate. The hourly rate is $300. And now we need to solve for the number of hours. So we just got this equation here with one unknown. So let's go ahead and solve it. So we're going to take 76,000 minus 16,000. That gives us 60,000 here. And now we're going to divide by 300. And the lawyer worked 200 hours. So if the lawyer works 200 hours, bills each one of those hours at $300 each, plus gets this fixed annual retainer fee of $16,000, the lawyer would have made $76,000. Question 9. A baker needs 2 ounces of chocolate to make 1 brownie. How many pounds of chocolate is needed to produce 100 brownies? So the ratio here of chocolate to brownies is 2 to 1. So we're going to solve for B, where B is the number of brownies and C is ounces of chocolate. So I'm just going to solve this equation for B. So we have this, you can think of this as a production function. So brownies equals chocolate, ounces of chocolate, divided by 2. So to produce 100 brownies, we're going to set this equation here, where B here, we're going to set that equal to 100. And now we're going to solve for C. So 100 equals C divided by 2. And if we multiply through by 2, C will equal 200. So we'll need 200 ounces of chocolate to make 100 brownies. So the baker needs 200 ounces of chocolate, and since there are 16 ounces in a pound, 200 divided by 16 means we need 12.5 pounds of chocolate. Question 10. The quantity supplied of a product is given by S equals 2P minus 10. The quantity demanded of this product is given by D equals 20 minus P. At what price does the quantity demanded of the product equal the quantity supplied? So we're going to set both equations equal to one another and just solve for P. So I'm going to add P to both sides, so that's where this 3P is coming from. And now I'm going to add 10 to both sides, so 10 plus 20 is where this 30 is coming from. And now dividing through by 3, the price here is going to be now $10. So at a price of $10, the quantity demanded equals the quantity supplied. Okay, I'll stop here.